Okay. To load. Okay, looking good. All right. Okay. There we are. All right. Okay. Last week I did a massive, almost 7-hour stream. And yeah, I wanted to power through to get it done. We did a lot of mechanical assembly, almost everything, but I couldn't get it done completely. It was too much. We sorted all the PCBs, did all the heated inserts. Only thing that's left now is cabling and software and a few aesthetics. Got my shop assistant here. Okay. Yeah. One thing I discovered. Let me. So let's put that away. Good. One thing I discovered. The ribbon cable in here is twisted, and therefore the chain does not bend completely right. And also it comes out wrong on this side. So we will have to do the cable chain again. And yeah, I will get my wife again. Still falls down all the time. Okay. Yeah, I left everything the same since last time. And so we could just pick up where we left. Feel like we need a little bit more light here. It's better. This one. This one. Okay. Yeah, okay. So the twist is, yeah, right. You cannot see this. Yes. Yeah, basically right here at the end. And this means we have to get it out completely to fix it. Maybe I will move my head a bit so you can see what I'm doing. Ah, that's better. All right. So, if anyone has any questions, please feel free to ask. There you can see the twist. There it was. Okay. Now the fun part is getting this back into the cable chain. Yeah, maybe from the other side. I think I will use the wire again. This is just, yeah. It's just some very thick wire, which I will bend to a little hook and then pull the ribbon cable through. Maybe you can see better here. No, a little bit. Yeah, maybe. Snipped out the other half of the tool because it kept falling down. Come on. Okay, so gateway through. Check if you have any twists. This looks good. Okay, no twists this time. Get this back in. Cat wants to help. Looking for the screwdriver. Okay. Now that's attached. Good. Okay. Last thing I wanted to do was the IDZ plugs. Yeah. Get this. Maybe. That's nice. Okay. So I want to check that I have the same orientation of cables and so on. But get like blue to white and green to white. Green to white. So they are basically like this. Yeah. Okay, IDC connected. They look like this. Put them on ribbon cables, and then you can, they have like special sockets for PCBs or I think even panel mount. And but you can also just push them on normal pin headers. Good. We want to have this. You know what? I made a test cable for this to see. Camera based cable chain test. So, okay. I made a shorter version of this. To get the polarity of these connectors right. And as you see, they are reversed in polarity. No, you can't see. I can get you closer. Here. So, yeah, they both start with the black lead on the left. And they make like a little loop like this. Okay. So, let's start with this one. It won't be so easy because the cable is split, but that way it's easier to get through the cable chain. There are bigger cable chains and also cable chains which you can open up. Panda Bear says hi. Which you can open up all the way. So you don't have to do the trick with the wire and pull it through, which is a pain. Just flip them all up and put them in. But unfortunately, this design is with a closed cable chain, so that's what we're gonna do. Come on. These plugs are also very fiddly, but they are not as worse as crimping, or not as bad as crimping. Okay, this looks good. I will use my pliers for this. So, nice pair of parallel pliers. Normally I would use a vise to, oh, you know what, a pistol. Pistol. These guys, they're great. Them open. Okay. And now you can see we can just crimp it together. Yay. It's a sting a lot. Yeah, there's always a bigger clamp. All right. Yeah. I think I did it wrong. Yeah. Yep, did it wrong. You see, this notch here should be on the back side because I want to lay it flat on the PCB. Yep, it's wrong. So yeah, we can just cut it off. I have access anyway. You can. Try this again. So notch goes to the back side. The reason why I want the notch there is after I put these cables through, like so, and I crimp them, I want to cut it flush because my pin headers on the PCB are angled, and that way I can mount them to the push them in better. So if the notch was down there, so on the other side, it would be in the way. But I can show you on the PCB. Good. Now, see, no notch. No notch. Now we can cut off the excess. Get a little bit more like this. Just with a sharp knife. Good. That really make it like a clean, close cut. Okay. That's looking good. Gonna show you closer. Yeah, you see. That is neat. Good. Now, there are these funny looking brackets. And what you do is you take the clamp, you bend it over its back, like so. And now you put this on. And these just snap on with a bit of force. No, or with a bit of clamp. Okay. So, and what you have now is a strain relief. Yeah, and because the way these angled brackets are designed, if you look, they have cutouts. Yeah, it's shaped like an H basically. And these cutouts allow you to bend the cable through. So if I bend this back over, like so, and now I have a completely flat-ish connector, which can go flat on a PCB. So that's the one thing. So that's gonna come up like here and then go into the PCB up there. The one that will be here. Yeah, okay. Good. Now, we have done this connector like so. This is my test piece. Now we have to do the other connector the other way. So basically, cat is already sleeping. Okay. All right. Good. So we start with, we have green on the left, blue on the right. It's like this. But these connector parts or these cable parts look pretty mangled from our pulling action. So I think I will cut them off. I don't want to risk like a broken cable in there. But I did this with plenty extra. It's really all right on both sides. Okay, so this goes there, blue to the right, and then we flip it over. Yep, yeah. So that's the trick. Yeah. So get you here. Like so. The notch is on this side, so on the cable side, and on the end side is the flat, the smooth part. Just thinking about how I'm gonna show this in the instructions. That's gonna there. Okay. One problem at a time. Okay. Get out. Oh. Let's just use the big clamp straight away. Okay. Good. Now knife. Cut off the excess. And now we twist it around for the strain relief, like so. Okay. And now this should be the other way around. Perfect. I think we did it. So, I'll see if I can plug it in, but okay. Okay. I can't show you any better, but this is now plugged in. I really need to get another light here, maybe from the left. Not today. So the motor cable. that's sorted. We could now finish the lid here and make like the power plug and power button and USB-C connector. So yeah, let's do that. You're getting the cat view again. He is completely knocked out. So, we have no. For this build, I decided to use USB-C because it's way more popular right now. It's a better connector than like micro USB. USB A type B is it? I think. No, USB B must be. Yeah, you know the one from printers. The big and bulky one. I like this one as well, but it's not so common that you can get good parts for it. I found like a pack of 20 USB-C sockets with leads on them already. And important part, 4 leads, so you get your voltage, ground, data plus, data negative. Yeah, because it's a differential signal. So, anyone has any questions in the chat, please feel free to ask. Since the last live stream, I've gotten quite a few comments, messages, an email about projects my viewers or people in general have done, and I've also seen some pictures of them, and it's really great to see that. So if you have any questions or a build you would like to share, I would love to hear it. Just there's my email address is on my channel page. You can just email me. I love to see other people's work. That's what I'm looking for. Right. Okay. So that's what we're making. This is the closer look. Too close. That's like the panel on the end of the slider. In here goes the power switch. That's 5.5 millimeter for 12 volt power, and this is a USB-C connector to connect the slider via USB. This will be, pulled all the way through the cable chain to the ESP32 on board, and from there you get direct contact to the USB to serial converter on the ESP on the ESP2 the reason I did it that way is you can just upgrade the firmware like that. You just plug in USB-C here, and now you have direct access to the board, so there's no additional serial converter. The downside to this is the USB to serial converter on the ESP2 is not very good. It's a CH340 or something. So it's not like an FTDI, like a good serial converter. It's I don't know what's wrong with it, but most of the times when I want to use it, I have to reinstall the drivers, even though they are already installed, and I just run the installer again, and then it works. Yeah, I don't know. Maybe it's just Windows 11 and all hardware. Okay, that's cleanish. Okay, yeah, cleaned up. It's okay. Good. Let's do first. There you. Hit the switch. So that's the hardware. It's a normal rocker switch. Switch is for like 230 volts, so way overpowered for this, but it's fine. Got a nice click to it. Then this nice and shiny 5.5 millimeter socket for power, and here USB-C with 4 leads already attached. To really dig Amazon to find this one, because all the ones only have power and ground. But this gives you a basic like USB 2.0 interface, which is all we need. It's good. So do I want to crimp or solder these? Let's do this one first. Oh, that's a different cable. Yeah. For the power cable here, I'm using nice 2-lead silicon wire, and we don't need a whole lot of length. Like, this should be enough. See if you can see this. Like, he has his tongue out. I think I have to move him before I solder, because the flux will spray. Yeah. Come on. Come on. Tired little guy. So cute, yeah. Yeah. You can see him in the back. He doesn't give up. Let him say no. What I'm doing next is like spraying soda flux, hot soda flux, and I don't want him to get hit. Yeah, okay. He has like 20 different places to sleep up here. Always. He is a fighter cat. Yeah, he always picks either my lap or my bench or my face. Next stream I'm gonna get a cat cam. Getting 1 million views. Alright, so I get you the other one. So we're gonna shorten the black wire a bit, but you can see, yeah, those are like different lengths. So and I should also put like heat shrink on. Or electrical tape. Let's do electrical tape. Okay. And now That is done. Thinking about heat shrinking it anyway, but yeah, maybe electrical tape will be fine. Nothing will happen. Nothing will explode. Let's just do the other side. So for this other side, we gonna crimp it. Away. It's a bit short. Good. The other one. Okay. So let's protect this with a bit of tape. This should do. Come on. Good. Okay. And now this goes into here. There we go. Pretty neat, right? So let's go over there. So I'm just gonna use my, you can either use like a, oh, what's it called? Missing all the words today. Like a wrench, I think. Yeah. Either use proper tools or one of these parallel pliers, because they don't gnar the socket here. So don't use like these pliers here. You're gonna destroy the surface. Okay. Let's see how I they're completely flush. Is this the right model? Yeah. Oh, I made it. I think the model of the switch is not entirely accurate, because it's like it has space in here, but in there it sits tight, too tight. Okay, we will have to revisit this, but for now I think this is good enough. It doesn't sit flush completely. No. These switches. Okay, that's okay. Okay. Another cable coming up. Another one of these. This. Did I mess it up? Or yeah, of course I did. Okay. Yeah. No. Yeah, what I mean by that is this switch interrupts 12-volt power. And I thought I had a second header for this on the PCB, but apparently not. So we have to connect the power directly to the switch and then to the power header on the PCB. But can see these, I can't see these switches, they have these flat tabs, and I have like crimping connectors for these flat tabs. And because there won't be any pull on them, this is completely fine. Let's see if I get the right size. A bit garbage. I'm gonna sort it. I'm gonna sort it, but this means I cannot, once they're in, they're in. I don't like that. Maybe if I just crimp the one. Yeah. Okay. But this won't hold. Oh man. That is poorly thought out. Okay. Here's what we're gonna do. I'm gonna test if this connection holds. And if not, we're gonna have to reprint this anyway. But then we are going to start cabling with the other components. Yeah. Yeah. Okay. But I don't think it will hold. It's a pretty thin wire. Not too thin. It's okay for the power consumption, but this connector is massive. Yeah. Okay. Let's try it. Ah, not a chance. Not a chance. Okay. Then, yeah. Okay. We're gonna change the part, reprint it. Where's the switch? Local switch. There. Okay. Okay. Now give it some tolerance. Good. Okay. check this. 6.2. .3. That's even. That's maybe a bit much. That is a bit much. Yeah. Let's only do this here. 5.8, that's already good. Okay, so yeah, maybe this was the problem as well. I think these walls are still too thick for it to grip on. So, okay, that's like a single layer there. Should be good. And how much relief did we have here now? 0.3. It's less than a nozzle. Let's push this out a bit. What are you doing? Okay. Yeah, okay. I have to eyeball this a bit. Yeah. Okay. Let's see, how does this sliced? Okay. So there's like a little recess then. All right. Okay. 3 hours. This is okay. Good. But I won't print this today. I'm gonna stream another 7 hours. Okay, good. So let's put the lid aside. And cable the head. Yep. Let's cable up this little guy. Do we have everything? Oh yeah, we could. But yeah. No, let's not get ahead of ourselves. Okay. I think I prepared the cable. It's this one. Because it also says tested, done. So let's see. Table. Yeah. Just joining, is that rail a C rail from open builds? The rail, you mean the one here? This guy here. What rail do you mean? Yes, that rail. No, that's a normal V-slot rail. You can get them from, anywhere. I found even like local metal suppliers have them. And because of like cheap 3D printers like Enders and so on, you can get them everywhere. It's pretty common now, the V-slot rail. Now it's on. Yeah, okay. Let me get you a better view of that. Okay. Better-ish view. So we have now the cable in, the rainbow cable in the back. And now we need power. I'm thinking all the time, I want to show you what I'm doing. But every time this thing is in the way. Yeah, I unscrew it again. Might be the best option. Yeah. Number 3. Serial from Open Builds. What exactly is Open Builds? Good. Okay. Power cable. Okay. Okay. So that's the power cable to power the CNC shield. It's a bit big to get it through here. Let's try here. Good. Okay, looking good. Good. Okay. Maybe we have to get out. Okay. So that's the biggest of all, the USB connection. But maybe it will fit. Okay. USB. Come on. Always the same with USB. Come on in. There you are. So that's very tight fit. It's a little bit bent, but it's okay. So motor cable. 6-pin. So I need a 4-pin to 4-pin motor cable. So just a little 4-pin to 4-pin. Get this through here. Twist it. Okay, and that is everything plugged in here. Just down there. Okay. Okay, let's see if the lid will fit. Looking for but to see the black surface with the lights, yeah. But the C-shape probe. Ah, okay. It's a maker shop in the US. Ah, I see. No. Yeah, I'm from Germany, so US shipping is very expensive. But V-slot rails, as I said, you can get anywhere. And it's a normal, what's it called, 2080. So, yeah. One with the 4 holes and one row. But I just noticed this stepper motor seems to be a bit bigger than the one in my model. Either that or the cable. Yeah, something is not right here. Let's see, it locks when I wanna shove it in. Okay, I have to check the model. There's a collision. And there is, oh man, was probably the last iteration or so. Is it on both sides? Yep, that sucks. Okay, let's do this. Okay. Yeah, what happened here is in like one of the last iterations, I moved the motor up a bit, and earlier this was fine because the motor kind of gets a bit wider at the bottom, and now this is in the way. Yeah, okay. Yeah, no problem. This would be nice. Perfect. Good. And let's see how long this will take to print. That's okay. Slice. 1 hour. Yeah, okay. Yeah. But I think I will do, yeah. What I normally do is do a complete revision. So I freeze one version here, like let's say 305, and then I look at all the things that have changed from the previous version, and I make a list, and basically a checklist to print everything. Then I print everything, check everything on the list, everything is printed, and then I go for each part, go through and do an inspection and a fitting and show if everything has worked, if there are issues with the print or with the design or something. And once this is cleared, I continue with designing. So there's always like a milestone or release. I found this helps like keeping quality up a bit, even if it's like a project that has so many components like this one. You see it's massive. It has so much stuff in it, and if you don't keep revisions, you will lose track of things. And also, if you print a bunch of things and put them all on your workbench, and some are newer revisions and some are older revisions, and they distinguish themselves by like 0.5 millimeter. Good luck finding that. Good. So this one is garbage, but we fixed it in a model. That's okay. So let's come back here. That's where we were. So now here we need 2 cables. These are 2x3 angled pin headers, and those are for these end stops. You can see here for the optical end stops. Let's see, I have prepared a bunch of cables first. So let's see. Prepare those. Those. Okay. So it's a normal JST here, but this is a bit long. I don't want to have all these cables in there. Let's do the upper one first. It's up. This one here. Balance it. Good. And these cables, they just come with the sensors. They have like 1 pin to pause for each lead. Yeah, okay. But I think I might have to undo these cables first to get to it, because I made a little cable chain below it. Let's see. That's the ESP-Duino. No, I'm gonna undo it. There, that's the cable chain. Okay, we are through. And this is in the cable chain. Cable channel. Nonsense. Okay. No, I don't have to zip tie it down, I think. It's okay. Now we're coming out here. And this is still way too long. Got like, yeah. Okay. About this much cable. And there's no cable channel under here, right? No. But then I have to think about how I route this cable. Because there's not a lot room above these connectors, and so between the connectors and the lid. That's good. Yeah. Like this maybe. Okay. Now comes the worst work of all, crimping. No, they are very tiny. Okay. This will be very hard to see. It's even hard to see for me, and I'm like 15 centimeters away from it. But we're gonna crimp on new connectors because we cut the excess off, so there are no more connectors there. And crimping is always just the most fiddly and agonizing work. No, come on. Okay. So, different crimping tool. This one. Whoop. Yeah, you're not gonna see any of this. I'm not not even gonna try. It's so tiny. Maybe it could be in focus at least. Yeah, it's a good crimp. Good. Another one. Yep. When I'm done, I'm gonna show you the crimped connectors. Such tiny stuff. Maybe you can see a bit of it. The closest I can get you. Oh my god. One left. Drill it. All right. It's okay. Good. Okay. Now we have to just slot them in. To slot them in the right way. All right, try this again. Here we are. What's that? Yeah, okay. It's the other ones. Oh, come on. What come back out again? Okay. Okay. Try this again. Let me see. Okay. I think they are a bit too wide from crimping. Yeah, that's better. Okay. Okay, now it's in. You see why I hate crimping. The other one's a bit bent. Okay. Blech. Okay. We have to see about the polarity of this thing. But the best part is we have to do another one. Thinking like something like that, lengthwise. This. So first thing, separate these. Separate these with looking. It's a bit. This. Those. Okay. All right. Okay. Tiny connector. Good. And the last one. Good. Okay. Let's make them the same orientation as these. So the one with the dot and the line is on pin 1. So other way around. It gets stuck again. It's too tall. Okay, so this one grips. All right, okay. So now we know this is ground dot slash is ground. I have to look it up. I did not mark it on the PCB. Can't see anything, right? So it's the PCB. Okay. This is clearly a ground connection. So these two outer pins are ground pins. Let's mark them. So this is that. Okay. Like this. That's neat. That's okay. Okay. Okay, it's the same there. That's good. Ground goes here. Nice. Good. That's in. And those are all the cables from here. The only thing that's missing is this one, the big ribbon cable from the cable chain. But now let's do the back. Too bad. That's the focusing distance of this. Okay. This cable here. One goes up to the PCB here, so through there. The other one, I have to crimp some more. Never stops. But okay. Let's get this all sorted through the cable channel. This can stay here, this can stay, this can stay. So maybe the other view is better. Zoom this in a bit. Oh, yeah, okay. Yeah, sharp-ish. Good. Yeah. So. Here. There we are. So this will come through here. Maybe I should have put it under the egg. Yeah, should have put it under there. But this one will go like that. then USB is connected and you cannot see any of that. Okay. Well. Okay, tuck this in here. That's okay. Yeah, you could even get like an angled micro USB connector here. Yeah. Getting tired. It's only 7. Getting old. Where do you want to go? Like this. Okay. Put this one down there as well. Maybe. Yeah, would be cleaner. The good thing is, in the build instructions and build video, you won't have to do any of this. It's all just me figuring it out here. Check if I do the motor as well. Do the motor as well. Do the motor as well. Okay, so they go all under there. That's not good. This here. It's just. Oh, you know what? That's a flat cable. Flat cables can go on top. Put this down here. Yeah, that's better. Okay. Now, the flat cable on top. And another flat cable on top. Now maybe this could go in the wrench as well. All right. This goes just flat on top. There we are. Okay. This looks pretty clean now, you know, apart from everything sticking out on top. But we will fix this. Yeah. Fix it here. And now. Yeah. And this is a slider motor. Slider motor X. X is sort of one in the back. This is long enough. Come on. Okay, first motor in. This stuff goes to the other PCB. And yeah. Okay. Let me show you. This is pretty neat. You know, this is going there. Yeah, it's okay. If the lid is on, no cable sticking out. Okay. Oh, man. What next? We could crimp some more, or we could do the other PCB. Let's do the other side. Put this aside for now. Okay. Too close. Good. So this is the second lid, the one for the tilt axis. If you nope, there we are. If you look in the model, come on. So this guy here. It's where all the plugs go for the camera and the focus motor and the trigger. Yep. And that's what we are assembling now. Good. We've done it last time. Pretty simple PCB. And I think I have the plugs done already. I only could find them. Didn't I solve them on already? Oh man, okay. Okay, we need this one. This. So those are the three things. This is one called like airplane style connectors. It's just like a 4-pin. So it goes in here. Yeah, we have to sort it first. I have not. No. Okay. So focus motor is here. Wrong name in the PCB. Okay. We will just need a very short cable. Maybe we can, yeah, I can take some of these offcuts. So we're gonna crimp this side again. Yeah. Okay. So now we need a 4-pin. A little 4-pin 2x2. See that? Tiny things. Let's do it 1, 2, 3, 4. So it's twisted. Generally, if you have these thinner cables, like this is just a cut off from a ribbon cable, it is easier to work with in crimping. The other cables we just did, they were just a bit thicker, so it's harder to get them into the connector, especially like these two pause style. If you have a JST, it's a bit easier. Okay. So now we got this little thing. The other side now has to go to this connector. So this means clear the isolation. And solder it on. before. Okay, we will have to check. Yeah, okay. This is one. Maybe I can get you close in. Yeah. Problem is the focus here. This lens cannot get, focus this close. It's normally a telephoto, but this will do. One. That is it. One. Oh man. There you are. A little guy. Okay. Yeah. Cool off. It's pretty warm. Yeah. Okay. But I think yeah. Okay. I think that's gonna have to do for today. Got quite a bit stuff done. The We can now reprint a few things like the lid and the slider and lid. These two lids. And we got all the cables in for the pan tilt section. And yeah, got a few crimp duns. Still hate them. All right. Yeah, I'll let you know when the next live stream will be where we can continue this. But thank you for watching and goodbye.